It's good to see all of you in my very first SF data science meetup. Jared invited me here today to talk to you about critical thinking and taming your biases. This is something that I taught for a number of years inside Facebook, where I worked as a software engineer. I worked in Facebook for a number of years on our internal data tools. And I was really interested in how people were using my tools to actually do the process of analysis. What decisions were they making based on my tools? And I quickly noticed that the most unreliable part of that process was the part that was in front of the keyboard. You might have noticed this yourself, just observing yourself, that our brains, while miraculously creative, are also very unreliable. So I became very interested in this topic. I did some reading on my own. I was very influenced by books such as Thinking Fast and Slow by Daniel Kahneman. Some of you might have read that book. Who's read that book? Daniel Kahneman came out maybe 3 or 4 years ago. It was a New York Times bestseller, really good book. In fact, I stole a bunch of examples for this presentation from that book. So if you recognize any of them, please keep the answers to yourself until your neighbor gets a chance to look foolish themselves. So that being said, let's talk about biases. Come on. Okay. First, some theory. There's many ways of looking at this, but a very simple, powerful way of looking at biases is that they all stem from two basic ways we have of thinking. Daniel Kahneman calls them System 1 and System 2. System 1 is fast, subconscious, automatic, frequent, emotional, stereotypic, and intuitive. It's always on, and it's effortless. And System 2, in contrast, is slow, it's conscious, it's effortful, it happens only when we ask it to. It's logical, calculating, and what we traditionally call rational. Okay? So the biases stem from the conflict in these two fundamental ways of thinking. So when I'm going to present the following examples to you, try to notice in your own mind whether it's System 1 or System 2 talking. Now, let's do a little demonstration to start off. So notice in your brain what happens when you try to solve the following problem. A bat and a ball costs $1.10. The bat costs $1 more than the ball. How much does the ball cost? Anybody want to venture an answer? Okay, yeah, first hand up was man in black.
5 cents?
That is correct. Yes. Okay. How did you know the answer?
X plus X plus 1 is equal to 1.1.
So you did the algebra in your head really fast. That's excellent. You were probably a star math student. Did anybody have the answer of 10 cents pop into their head? Yes, good. A few people are not too embarrassed to raise their hands. I'm sure at least double as many had that number pop in their head. Where does that come from? System 1, right? It looks easy because there's a dollar, there's a dollar, and there's a 10 cents. There's a bat and there's a ball. Our System 1 just pops up an answer right away, and it takes System 2 to say, no, wait a second, that can't be right because the algebra doesn't work out, and then you have to think it through step by step. The point is not that people can't solve these problems, but that that our minds produce predictably wrong answers. In fact, when and this is even true of really smart people. When students of Princeton, MIT, and Harvard were asked this question in psychology experiments, 50% of them failed to answer correctly. All right, so now let's get closer to home. Suppose that you're in a company with me, and we make Airbnb for dogs. We call it dog B&B. So this is when you want when you need a home for your dog when you're on vacation. We just launched this project. We're really enthusiastic about how it's going to do in the market. Okay? We analyze the first bit of data, and we find that the top states per capita tend to be sparsely populated rural states in the Midwest that vote Republican. The top usage happens in these states. How would you explain this? Any ideas? Just, you can blurt them out.
More dogs.
There are more dogs in those states. Okay, possible, definitely. And in the back? There could be more dogs per capita, yep. Yes, in the front.
Fewer other options.
There are fewer other options, yeah. It could be that they're this underserved market. All right. These are all really possible answers that you might want to look into, but there's another explanation which is purely statistical. That is that the smallest states in the United States tend to be sparsely populated rural states in the Midwest that vote Republican in elections. And if you're looking only at the top of the distribution, you're going to see the smallest samples out there. So by random statistical chance, the smallest states are going to be at the top of the distribution. Does that make sense? Like imagine a bell curve. You have big states and small states. The big states will be clustered in the middle. The small states will be at either extreme. So by that logic, even if there's no fundamental difference, you would expect to see the Republican sparsely populated Midwest states in the top of the distribution and in the bottom of the distribution. Okay? It takes some effort to think this way. When we read a result like this, our minds naturally start to think about everything else we know about those states, about like living on farms and things like that. And that could have something to do with it, but it's really helpful to also think about just the underlying statistics of what we're trying to measure. Sound good? Okay. This phenomenon, this bias of generalizing from any number is called the law of small numbers. It's a joke in contrast to the law of large numbers, which you may have learned in your first year stats course. Law of numbers says that the larger the sample, the better the statistics. In everyday life, we don't think that way. We're ready to generalize from any sample any size. You know, oh, I heard a friend, you know, got food poisoning. You know, never go to this restaurant kind of thing, right? There's some truth to it, but clearly we're not taking sample size into account. Okay, next example of a bias. So we're still working in Dog B&B. It's growing fast. In a survey of 120 dog owners found on SF Craigslist, 65 said they would use Dog B&B. How would you summarize this finding to the rest of the company? So you're working as a data scientist. It's your job to do these things, to run surveys, to conclude, and then summarize. And you have to write this out in a one-line summary in your company's weekly report. How would you do that in 10 words or less? You know, you can just think about this in your head and use your fingers if you need to. Okay, 10 words or less. Anybody want to volunteer a summary? More than half of dog owners on SF Craigslist would use Dog B&B. That's what I heard. Good, that's a good summary. That's really close to what most people come up with. And when you try to summarize even more, what happens? You know, try to summarize that finding in 4 words. Can you do better than this? What's so hard about this? We summarize information all the time. Precision. I didn't hear where that came from, but that's a really good one-word answer. Very, very concise answer. We lose precision when we summarize information. So to retain some meaning to the sentence, we need to take out all the qualifiers, like the sample size, for example. Originally, the information I presented was 120. That's lost in all the summaries. Now we don't know how big the sample is. That's a loss of precision. But that's a fact of life when it comes to summarizing information. There is a bias of confidence over doubt when summarizing information. You could also call this the headline effect. So like the headline of a newspaper story is always going to sound more confident than the text of the story that follows. This is unavoidable. And your job as a responsible data scientist is just to do this honestly and point people to the rest of the story so that they can fill themselves in if they want to. Okay, next bias. On a scale of 1 to 10, where would you put each of these words? This is an example of another thing we do all the time without thinking. When somebody asks you, like, how fast was revenue growing last month? When you say it was growing fast, really fast, super really fast. In everyday speech, we use words to stand in for numbers. How do we do that? It's a mystery. It's a black box, right? And people may think they know what we're talking about, but it can be really we can be really quite far apart. So, for example, let's take a poll here. So, if I say that something is likely to, or no, I'll take a better one. If I say that if something is likely to happen, tell me whether you'd be comfortable using that word on a scale of 1 to 10. Okay, let's do a group poll here. I'll just count up from 1, and then you raise your hand when you're comfortable saying, yeah, this quantity I'd say is likely. Okay, so 1 out of 10, probably nobody. 2, 3, 4, 5. Raise your hand so people can see. 6. Okay, a lot of people. 7. A lot more people. 8, 9, and 10. Do we have any absolutists? Okay, cool. So it seemed like the bulk of people were in the, 6 and 7? But if you plotted this out, it would probably be a normal distribution itself. So we're estimating individually what does the word likely mean. And it's really cool that we can do this. We can do this really fast, but it leads to a loss of precision again, and it can be the cause of bias. So this process is called intensity matching. So back in my Facebook days, I found a really shocking example of this in the popular press. The site, thedailybeast.com, reported a finding on a survey with the headline, "Few Facebook users click ads." In a CNBC poll, a full 83% of those surveyed said they hardly ever or never clicked on Facebook ads. Did you see the intensity matching here? Yeah, there's a double case happening. That one, the people are asked to quantify their own clicking behavior, which is not clear how you do that. And then the journalists summarizing the results summarized the 83% into a headline of few. At that point, in my opinion, all precision is lost, and you could easily tell the opposite story by saying many Facebook users click ads. You could completely reverse the headline using the same data, just because it's not clear how people rate these qualities. Any questions so far? Okay. Okay, yeah, for this next one, I will ask the audience to participate in an experiment. Conveniently, we have a bank of chairs here and a bank of chairs here. I'll call this group 1, and everybody who's further to the left can be group 1, and over here and further to the right, group 2. Okay? So group 2, I kindly ask you to close your eyes for 15 seconds, maybe 30 seconds starting now. Group 1, please read the slide. Answer both questions and keep the answers to yourselves. Okay, group 1, freeze your answer. Don't change it. I'm going to show group 2 now. Group 2, please open your eyes. Read both questions. Think of an answer. Group 1, don't change your answers. Okay, I think that's about the same time as group 1 had. Group 2, please freeze your answers. Now we'll take a poll. Okay, group 2 saw the second slide. So group 1, you've seen both now. Now group 2, it's your chance to see what group 1 saw. What's the difference? There's only one small difference, right?
600 million and 300 million.
Thank you, 600 million, 300 million. How do people feel that will change the responses of the two groups?
One would have overestimated the number of active users.
Yeah, one of the groups will overestimate. Group 1 would be expected to overestimate, because they received 600 million and second 300 million. But notice that they're logically the answer to the second question does not depend on the first question. So let's see how the science holds up here. So for let's see, we'll do this in blocks of 250 million. So group 1, raise your hand if, okay, we'll do both groups together to speed this process up. So raise your hand if you guessed the answer to the second question. How many active users did WhatsApp have when it was acquired? Raise your hand if your answer was between 0 and 250 million. Okay, take a look around, make an estimate. Okay, next block, 250 to 500. Okay, and 500 to 750. Okay, I'm seeing slightly more in that block, group 1, and then 750 or higher. Okay, raise it high. This is more interesting. So we got maybe 4 in group 1 and 1 in group 2. Okay, that is evidence for the phenomenon of anchoring, right? Group 1 saw a higher number stated in the question, in the first question, and that influenced them to a higher answer in the second question. Okay, this phenomenon is really prevalent in everyday life. When you go to the gas station, there's the gold, silver, bronze kind of levels, and you might think, why would you ever pay more to pay for the gold? I'm just going to buy the silver. Well, you might be victim of anchoring then, because the marketers know this. They always put the higher prices out there to draw you up on the price spectrum. Make sense? So this can affect your own work, deliberately or indeliberately when you're seeing different contexts. If I'm anchoring my numbers of my current startup against the numbers of Facebook, I might be quite skewed. Okay. Similarly, let's try another quick experiment. This one, again, I'll ask Group 2 to close your eyes for 20 seconds. Group 1, read the slide. Answer the question, keep the answer to yourself. Okay, that's enough time. Freeze the answer. Group 2, please open your eyes, and now you give it a shot. Can everybody see back there? Sorry if it's a little, the text is a little small. Yeah, well, the text size should affect both groups equally, so our results are still good. Okay, now I'll say this is what group 1 saw. This is what group 2 saw. What's the difference? The group 2 received additional information. The first 2 paragraphs are the same, but group 2 saw additional list of steps required to complete, or suggested steps for the completion of the experiment. What do you expect the effect of that to be? It's going to increase the estimate, right? Even though group 1 should have been fully able to think up the same steps required. I mean, that is to say that experiments all require these steps in some sense. Okay? So let's do a quick poll again. How many people, raise your hand if you thought it was going to take 1 day to run this experiment? 2 days to a week. Okay. 1 week to 1 month. Okay. And then 1 month or longer. Okay. It's a little bit hard to judge because group 1 obviously is much bigger, but just looking at the chairs sections, I'd say group 2 was skewed towards longer experiment completion time, which is what we'd expect according to the planning fallacy. So this is something that, even without the name planning fallacy, you probably recognize from your day-to-day work. It's really easy to just give an estimate off the top of your head saying, oh yeah, I'll get that done by next week. And then when you get back to your desk and you think about it, you're like, holy shit, there's no way I can get this done by next week, because you actually have a little bit more time to think through the steps involved. The planning fallacy is that we tend to underestimate. We tend to estimate by just thinking like, oh, what do we need to do? But the more you ask that question, what do you need to do, the more things you come up with and the more you realize the work involved. So it's a really pernicious bias. It affects, yeah, question?
I was just going to say that this affects like all the software developers I've worked with, especially when estimating how long will it take to fix a bug or implement.
Yeah, it's even worse. It affects the whole world. It affects, probably like the Bay Bridge. City projects are notorious, right? Everything, because everything takes more than you initially you're capable of thinking of. Yeah.
Do you think the deviation would reduce in group number 2 because more data is given, so they would be able to give an answer which is more or less the same, whereas group number 1 would give a random estimate from
Right. Yeah, so the question was, would you expect the additional information, the additional level of detail to also reduce the spread in the responses? I would agree with that. I haven't looked into that. I haven't read anything about that. Yes?
One of the things there is that there's no information about the quality of their team of engineers or product people. So for example, if you had somebody like, a really amazing type team that was like just 4 people, right, they could probably solve in terms of like really high quality. They, regardless of what, the quantitative information in terms of like planning, right, they could quite easily kind of like just basically like compress whatever the estimate is.
Yep.
So there's no information about the quality of the team.
No. No information about the quality of team. This is probably a learned skill also. People can learn to get better at estimating. Yeah, this is just changing that one variable in the information. So yeah, good ways to get around this fallacy is practice, just noticing your own estimates and how close or far they're off, and then also taking the outside view. That's something that's advocated in the book, Thinking Fast and Slow. Don't just think about what you know needs to get done. Just think about what other projects, what similar projects have been done in the past, and how long did they take to complete. So you're benchmarking against some independent project. Okay. Okay, one more experiment here. Okay, ready, group 2, close your eyes. Group 1, read the 2 paragraphs. Make an estimate. Okay, I think that's enough time. Freeze your answers. Group 2, please open your eyes. Thank you for waiting patiently. Now it's your turn to answer the question. Again, I apologize if the text is too small in the back. I'll read out the question. In May 2016, people viewed more videos on Snapchat than on Facebook. 1 year before, in May 2015, how likely would you have expected this outcome to be? Give an estimate on a scale of 0 to 100. Okay, freeze your answers. Now I'll show you group 2 what group 1 saw. You tell me what's different. Okay, so in one of them I lied. Right? As they both can't be true. As a matter of fact, I don't even know which one I lied in because when I looked this up online, we're just about to announce that Snapchat had overtaken Facebook in video views. Now the definition of what a view is not the same, but the point still stands. What's interesting to us tonight is whether you would have guessed this a year ago. Okay, let's see how people guessed. So, really simple this time. Raise your hand if you thought it was 50% or less to your question. Less than 50%, okay. Okay, and more than 50%. Okay. I think there was maybe about 60% of the people answered there was 50% or higher overall. What's wrong with that? If both groups are seeing the logical opposites and both are saying 60%, I thought that was going to be true, what's going on? Anybody want to take a stab? Oh.
After the fact, you rationalize the result that you think you missed it.
After the fact, you rationalize the result that you know to be true. Right. That's a really good explanation. In the literature, it's called hindsight bias. So again, this is like common sense, but scientists have proven common sense to be true. People do rationalize. Okay. We just saw it here, perhaps, that people were presented two opposite statements and unknowingly to each other, two groups, and each group on average said about 60% thought it was likely to happen. Okay, we'll skip this one in the interest of time. Yes?
Can you explain the hindsight bias again? I didn't get that.
Yep. So hindsight is refers to like looking back in time, and when you do that, and you know you're talking about something that happened now, it's really easy to say, oh, I knew it was going to happen all along. Yeah. You can also call it like the rear view mirror effect or something like that, or I told you so effect. It's easy for people to be influenced in thinking about the past, about what's happening in the present, even though logically, in the past, you couldn't know anything from the present time. Confirmation bias, I'm going to skip over this one in the interest of time. You can look this up along with any of the other ones on Wikipedia. There's a list of biases. It's a fun way to kill 15 minutes. Now, this one could be a lifesaver for you guys. How would you rank by chance of death each of these forms of transport? Could be a lifesaver. Air, bus, car, bicycle, foot, or motorcycle. Rank them from safest to most lethal. So I'll let you just do this one in your heads. Now you can compare to the actual results according to Wikipedia. Surprise, they are in exactly the same order that I originally presented them. Any surprises here? I was really surprised by how relatively lethal bicycle travel and foot travel is. Yeah. Motorcycles are just plain dangerous. Yes, in the back. I don't. That's a really good question. Unfortunately, the data is just not there on Wikipedia. That's right. Yeah, and the whole definition of what constitutes foot travel is up for debate. You know, people walking around their homes, is that foot travel? I don't know. So anyway, it's kind of interesting, right? And I think you did this repeatedly, you'd find the same response from people, that people would undervalue things like bicycle travel or foot travel or bus, right? Because when we answer this question, we don't actually do the math in our head because we don't know the number, or at least it's really unlikely that any of you work for like transport agency and you actually know what the number of fatalities is. Instead, we answer a much easier question in our minds, which is how often have you heard of fatalities? How many people you know have been in car accidents and that kind of thing. And this is called the availability heuristic, whatever is available to memory. And it's associated with availability bias, right? Because we don't just remember how frequently things happen, we remember things in proportion to their intensity. So the more intense something is, the more grisly an accident, the more likely we are to remember it. And so when it comes to estimating the frequency, we overweight things by their intensity. And this is, again, a common sense phenomenon. Science has proven it once again. You know, it's closely related to the phenomenon of sensationalism in the news. The news loves to show the most intense things possible, and then people come away with the feeling that, wow, this is happening all the time because it's always on the news. But that's just not true, as the statistics show really strongly. And it's interesting to think about also how this becomes even worse with the advance of technology because the power of media is growing more and more. So the ability to spread the really intense stories is increased all the time. So we could all be becoming more biased by availability. All right. Okay, the final bias I want to present to you is something that you can take home with you to your next dinner party, or maybe you can take it to happy hour. I warn you, it's really Only a good idea to pull this out if you want to start an argument or a heated conversation. The question is, which I invite you to ask, is why do intelligent women tend to marry men that are less intelligent than them? Anybody care to answer?
Well, the guys can't answer.
The what can't answer?
I think the guys can answer.
The guys can't answer. Oh, it's starting now. Yeah. Okay, inside, yeah. Because they're more attractive? Okay. Okay, let's get somebody, yeah, in silver.
You presented to us a question that has a bias in it, so we have to answer it in this way.
Because I presented a question. There is a bias, yeah.
It's an assumption that this is actually true.
Yeah, there's an assumption that it's true. I would argue that it is true based on first principles, which I'll explain in a moment. Yeah, in the front.
Is there more men that are less intelligent than men that are more intelligent? So it's more likely that the embarrassment is less intelligent?
Yes, so that's what I was getting at. There is a trick to this question that by presenting it as intelligent women, I'm presenting a smaller group against a larger group of men who are just the average male population. So all else being equal, assuming nothing else, you'd expect that those women are going to choose from the general population of men, and the general population of men, on average, is less intelligent. Does that make sense? You know, that's a stronger response than I was looking for. This phenomenon is called regression to the mean. Okay? Yeah, comment in the front?
I was going to make the observation that even the first word, in terms of why, it's actually about like qualifying something.
Yeah.
Whereas in actual fact, it's actually like if you had said like how many intelligent women marry men
Right.
or less, it would be like a quantification thing.
Yep.
So there's like a trick, a mind trick inside us.
That's a really good point. A lot of this stuff comes down to language, and language cues different ways we have of thinking about things. And when you present a question with why, you start thinking about causation. And in normal life, we think about causation of character traits, you know, intelligence, strength, laziness, and all these character traits. That's how we explain why people do the things that they do. We don't think about regression to the mean. It's an impersonal statistical thing. We don't think of that as a cause normally, but it can be a cause, or it can lead to these things that look like they're caused by other things. And when I present a question that has really strong political strength, right? Because we're in a society right now where we have a lot of talk about equality of men and women. A lot of different ideas come to mind, and they crowd out all the other ideas of just plain boring statistics. If, on the other hand, I presented the question, why do blondes tend to marry brunettes? It's much easier to think about. Notice that. Because clearly there are many fewer blondes in the general population than brunettes. Right? Does that make sense? Yeah. And there's no political debate about whether blondes are equal to brunettes. Or hopefully not. Hopefully we're past that. Yeah, so again, that's called regression to the mean. Does anybody have any more questions about biases, heuristics, anything you come across in your own work? It's okay, you don't need to say anything now. I'll be around for the next while we enjoy each other's companies. You can come up and ask me anything. My name is Greg Dingle, Greg at Parsub. I want to thank Jared for inviting me here to speak to you all today, and Galvanize for the space, and Daniel Kahneman and all the other countless scientists for solidifying this knowledge for us to use. Okay, thank you very much.